Now we shall see an example with square root. Say f of x is root of x square minus 16. We are going to find domain and range, and there is no denominator, but there is some square root here. Whatever inside the root should be positive, so x square minus 16 must be greater than 0. I wrote x square minus 16 as x minus 4 into x plus 4 greater than or equal to 0. So case 1, both x minus 4 and x plus 4 greater than or equal to 0. So x is greater than or equal to 4, x is greater than or equal to minus 4. Something which satisfies both of them is nothing but 4 comma infinity, because 4 to infinity only satisfies both the conditions. Now case 2, x minus 4 is negative, that is less than or equal to 0, and x plus 4 is also less than or equal to 0. That means x is less than or equal to 4 and x is less than or equal to minus 4. Something which satisfies both of them is nothing but x is less than or equal to minus 4. So thus in the cases, for case 1 we have 4 comma infinity, second case minus infinity comma minus 4. So domain of the function is nothing but union of these two things, minus infinity comma minus 4 union 4 comma infinity. Now to find the range, we have to make f of x equal to y. So x square minus 16 equal to y. On squaring either side, we get x square minus 16 equal to y square. So x square equal to y square plus 16, x equal to root of y square plus 16. Okay, y has every right to have any number here, because y square is always positive, y square plus 16 obviously be positive. So y can take any value, but we have to keep something in your mind that square root function having only positive values. The range is subset of set of positive real numbers. So the range must be 0 to infinity. Now let us see, is there any short way to find the domain? Yeah, there is a shortcut to find the domain. You just draw a number line, and that x square minus 16, when you make that x square minus 16 equal to 0, you may have x plus 4 into x minus 4 equal to 0, so x equal to 4 and x equal to minus 4. You just draw a number line, plot the points minus 4 and plus 4 in between minus infinity and plus infinity. Then now take one sample point in those intervals. Say from minus infinity to minus 4, say minus 5. If I substitute minus 5 inside that, for the value of x, it will be like minus 5 the whole square minus 16. So minus 5 the whole square is anyway 25. 25 minus 16 positive. Okay, it is acceptable. So x can take the value minus infinity comma 0. No problem at all. Now take one sample point from minus 4 to plus 4. I took 3. You can take anything like 1 or minus 1 or 0 or whatever. Okay, I just take 3. When I substitute 3 there, 3 square minus 16, which is 9 minus 16 minus 7. It's root of negative. It is not at all valid. So x does not belongs to minus 4 comma 4. Now take the another interval, that 4 comma infinity, say suppose 5. 5 square minus 16 will be 25 minus 16, which is 9. 9 is positive number only. So root of positive quantity is acceptable. So it's valid. So x belongs to 4 comma infinity. Now the domain is union of those two things which already we found acceptable. Minus infinity comma minus 4 union 4 comma infinity. Now shortcut to find range. To find the range, after rating x in terms of y, do the similar thing, but keep in mind that range is a subset of positive real number when there is a square root function involved. So no negative numbers are involved here. Okay. When x is equal to root of y square plus 16, that what we got. Then y square plus 16 obviously greater than 0, because y square is greater than 0. Y square plus 16 obviously greater than 0. So y can take any value, anywhere, any value, all the values. But already we knew that y is always a subset of positive real number. So 0 to infinity, every value to be taken. So the range of the function is 0 to infinity. Now let's see one more example. To find the domain and range of f of x equals root over 36 minus x square. Okay, to find domain, we need to make whatever inside the square root should be greater than 0. So 36 minus x square greater than or equal to 0. Factorize 6 minus x into 6 plus x is greater than or equal to 0. So both 6 minus x and 6 plus x must be positive, or both of them can be negative. In order to make the whole thing positive, positive into positive is positive, or negative into negative is also positive. So in first case, minus x is greater than or equal to minus 6, comma x is greater than or equal to minus 6. But minus a greater than or equal to minus b, when you multiply through negative, a less than or equal to b, I know. So x is less than or equal to 6, comma x is greater than or equal to minus 6. Thus here x belongs to minus 6, comma plus 6. Now case 2. 6 minus x is less than or equal to 0, comma 6 plus x is less than or equal to 0. Both of them less than 0, less than or equal to 0. So minus x is less than or equal to minus 6, comma x is less than or equal to minus 6. X is greater than or equal to 6, comma x is less than or equal to minus 6. What? How can this be? It's like someone to be born in between a brother and sister, two brothers, A and B, elder than the elder one, younger than the younger one. It is not at all possible, so null set. So x is union of these two things, so it will be like just minus 6 comma plus 6. Now to find the range, we have to make y equal to f of x, so y equal to root of 36 minus x square. To get x in terms of y, you need to square either side. So y square equals 36 minus x square, x square equal to 36 minus y square, x equal to root of 36 minus y square. Okay, here that 36 minus y square should be greater than or equal to 0, and keep in mind that y must be greater than or equal to 0 because it's a square root function. Well, if you factorize that, it will be like 6 minus y into 6 plus y is greater than or equal to 0, comma y greater than or equal to 0. Once again, for the case 1, both of them positive, both the factors 6 minus y and 6 plus y, comma x, y greater than or equal to 0. So if you end up getting like, it will be like actually minus 6 comma 6, but when y is greater than or equal to 0, that's why we get 0 comma 6. In the second case, as I already we have seen that it's a null set, similar to that domain thing. So thus the range is 0 comma 6. Now we may use a shortcut to find domain and range. The same function, 36 minus x square greater than 0, factorize 6 minus x into 6 plus x equal to 0. So the turning points which converts the expression into positive to negative or negative to positive is minus 6 and plus 6. Plot these points in the number line, minus infinity, then minus 6, then 6, then infinity. If you take sample points in between like minus infinity comma minus 6, I suppose minus 9 be one of the number there, and if substitute in that whatever inside the square, 36 minus x square, we get negative. And whatever between minus 6 to 6, one sample point I took 0, 36 minus 0 square positive. So from 6 to infinity, 8. You can take any number, but 8, I took 8. 36 minus 8 square is again negative. So wherever we get positive is nothing but minus 6 comma plus 6 only. Thus the domain is minus 6 comma plus 6. Now similarly, when you make y equal to f of x and y equal to root of 36 minus x square, we get x equal to root of 36 minus y square. Even though the minus 6 to plus 6 satisfy all those points here, but one condition is y is greater than or equal to 0 for a square root function. Therefore 0 comma 6, when you look at the number line, you can see that the line been shaded as red, 0 comma 6 is the only correct region, all other things are wrong. Thus the range is 0 comma 6. Now the next example is f of x equals root of 2 plus x divided by x minus 3. Now to find the domain, it's obvious that whatever inside the square root should be positive. So 2 plus x greater than or equal to 0 and x minus 3 greater than 0. Why just greater than 0? Because it's the denominator. Okay, or 2 plus x negative, x less than 0. There is 2 plus x less than 0, comma x minus 3 is less than 0. Here 2 plus x can be less than or equal to 0, but x minus 3 less than 0 only. Now case 1, 2 plus x greater than or equal to 0, comma x minus 3 greater than 0, we end up getting x is greater than or equal to minus 2, x is greater than 3. Something which satisfies both the condition is 3 to infinity. Now for the second case, 2 plus x less than or equal to 0, x minus 3 is less than 0, that means x is lesser than or equal to minus 2, x is lesser than 3. So that means all those values are lie in between minus infinity and minus 2, because all those things are lesser than minus 2 only. So x belongs to minus infinity comma minus 2, thus the domain is union of those two things, minus infinity comma minus 2 union 3 comma infinity. Now to find the range, we have to make f of x equal to y. So root of 2 plus x by x minus 3 equal to y. Okay, squaring both the sides, we get 2 plus x by x minus 3 equal to y square, cross multiply. Okay, you know all those steps. Keep all the terms which contain x on one side, on the other things on the other side. Finally we get x is equal to 3y square plus 2 by y square minus 1. But y square minus 1 in the denominator, it shouldn't be 0. So y plus 1 into y minus 1 not equal to 0. So y not equal to minus 1 or plus 1. But you know, y must be subset of all positive real numbers. So y cannot be negative. Thus range of the function is all positive real number except 1.